Hello everybody and welcome to this video. In this video I'm going to show you how to specify a multiple regression model and estimate it based on the robust Satorra-Bentler method. So this is our model. As you can see, we have two predictors, factor 1 and factor 2, and one outcome, which is factor 3. Factor 1 is interpersonal conflict with 4 items, and factor 2 is a role conflict with 3 items, and our outcome factor is negative affect with 4 items. Note that we don't have any scaling items here for factor 1, factor 2, and factor 3, and instead I have fixed the variance of factor 1 and factor 2 as well as the variance of this disturbance term to 1. Okay, now let's go to EQS to specify and estimate this model. Okay, first let me open the data file. So this is my data file, and again, similar to our previous example, I'm going to use new model helper feature in EQS to build the model, and I'm going to select factor model. Okay, now I'm going to define my factor 1, factor 2, and factor 3. So factor 1 is interpersonal conflict with 4 items, IC1 to IC4. The second factor is interpersonal conflict, role conflict with 3 items. And the third factor is negative affect with 4 items. So F3 will be factor 3 or negative affect. Alright, now factor 1 and factor 2 are my predictors, and factor 3 is my outcome. And I allow the two predictors to covary, and it's done. So this is our bivariate regression model. Alright, in this example I'm going to fix the variance of factor 1 and factor 2 to 1, and also the variance of this disturbance term, and therefore all of these factor loadings will be estimated. We will not have any scaling items in this application. So what I'm going to do is to fix this factor loading to allow this factor loading to be freely estimated, and also this one and this one, and I will also fix the variance of factor 2 to 1 and for factor 1, and also for this disturbance term. Alright, now as you can see, all of the factor loadings will be estimated. The variance of factor 1 and factor 2 as well as this disturbance variance have been fixed to 1. Alright, let me save this model as model 1. Alright, now I select title specifications from build EQS menu. I always select robust methods because I would like to see the robust statistics in the output, and then I click OK. Alright, so again you can see that I have 75 variables and 2000 observations in my data file. The analysis is based on maximum likelihood and robust, and also the analysis is based on covariance. My data comes in raw format, and this is the address of my data file in my computer. So you can also see the variables and the label of the variables in my data file, as well as the equations that define my multiple regression model. You can also see that the variance of F1 and F2 have been fixed to 1, and the variance of D3, or the only disturbance variance in my model, it has also been fixed to 1. The asterisks indicate that these parameters will be estimated. So all of these factor loadings for the items will be estimated in my estimation. All of the residual variances will be estimated as well. And we have one covariance between factor 1 and factor 2, and as you can see, this covariance will be estimated as well. The fit indices will be displayed in my output, and the results will be displayed in equation format. I'm going to change this to compact format. Alright, and I'm done. So let me just save this as model 1. This is my EQX file, as you can see here. And now I can simply run the model. Alright, again, let me go to my EDS file or my diagram file. To view the parameter estimates, you can simply select parameter estimates. So these are all of the unstandardized factor loadings. Note that the variance of F1 and F2 have been fixed to 1. They have not been estimated. And also the variance of D3, it is also 1. It has not been estimated. These are all of the estimated residual variances and also the unstandardized pass coefficients that you can see here. This is the correlation between factor 1 and factor 2. And these are the two passes from factor 1 and factor 2 to factor 3. These are unstandardized estimates. If you would like to see the standardized estimates, you can simply select a standardized solution. Now, this is the correlation between the two factors. This is the standardized pass coefficient for the effect of F2 on F3. This is also the pass coefficient for the effect of F1 on F3. You can also see the standardized factor loadings here, and all of them seem to be okay. Now let's go to our output file to see the rest of the results. Okay, again, you can see the univariate statistics here, the means, skewness, kurtosis, and standard deviations of all of the items in the model. You can see that our normalized estimate of multivariate kurtosis is 53, which means that our data are multivariate non-normal, and therefore we have to consider the robust statistics for the purpose of interpretation. Also here you can see the top 5 cases with the largest contribution to the normalized multivariate kurtosis. So these are the case numbers of these 5 cases, and these are their estimates. Comparing these estimates show that the case with the case number of 934 and the case with the case number of 1415 are extreme outliers comparing with the other case. So before interpreting the results, I'm going to exclude these two cases from the data file and run the model again, and then we will review the rest of the results. So let me just close this. I will go to my EQX file, and to delete the two outliers, I simply go to title specifications, delete cases, and here I have to select the multivariate outliers. So one of them is the case with the case number of 934, this case, and the other one is the case with the case number of 1415, which is this one. Alright, now you can see that these two extreme outliers have been excluded from my analysis. I just save the model and run the model again. Okay, now let me scroll down to review the results. This is the new normalized estimate of multivariate kurtosis. It is still above 5, which means that our data are multivariate non-normal. Note that we don't have any extreme outliers in our data file anymore. Let me scroll down. Okay, parameter estimates appear in order and no special problems were encountered during optimization, which means that our results can be trusted. Now let's go to the robust fit indices. These are the fit indices based on the traditional maximum likelihood. We are going to ignore these statistics here because our data are multivariate non-normal. So we focus on the robust fit indices. This is the Satorra-Bentler scale chi-square, which is 537.54, and the degrees of freedom is 41. You can also see the rest of the robust fit indices here. And in this table, you can see the factor loadings and pass coefficients that have been estimated. Remember, all of the factor loadings and pass coefficients were estimated in our analysis. So under the B, you can see the unstandardized version of the factor loadings and pass coefficients, and under beta, you can see the standardized version. And also note that since our data are multivariate non-normal, we are going to skip the traditional standard error and Z statistics, and we focus on the robust version of these statistics. So you can see that all of these factor loadings and path coefficients are statistically significant. You can also see the R-square values here, and this is the R-square value for our outcome factor for negative affect, and together interpersonal conflict and role conflict explain 32.1% of negative affect in our model. Here you can see the results with respect to the variances. Note that the factor variances for factor 1 and factor 2 as well as the disturbance variance were fixed to 1. That's why they have not been estimated here, and these are the residual variances that have been estimated, and these are the robust standard errors and Z statistics. You can see that all of these residual variances are statistically significant, and here you can see the correlation between factor 1 and factor 2, which is 0.488, and it is statistically significant. Here at the end of the results report, you can see the standardized solution. These are all of the standardized factor loadings that seem to be okay. You can also see the standardized path coefficient between factor 1 and factor 3, which is 0.374, and between factor 2 and factor 3, which is 0.280. And again, this is the R-square value of negative affect, which is 32.1%. And at the end, you can see the correlation between the two predictor factors, which is 0.488. Okay, it was all I wanted to share with you. In the next video, I'm going to estimate the same model but using the robust PLSE2 estimator. Thanks for watching, and I hope you enjoyed this video.